Hi everyone. Now we will plot one more graph. So how it looks like. This is y equal to 2 power x. Just observe one thing that x is not at the base position. It is at the square, the power position. Here x is at the base and 2 at the top. Don't get confused. It is 2 power x. Okay. So now let's see how this graph looks like. So for the graph, what we do, we'll take some arbitrary points when x equal to -1, 1. So how the y behaves. So that's what. So we take some few points like we go by the integers. Sometimes we go with the fractions, but not right now. So this is simple with the integers. Okay. As usual, let's take 5 points. So some negatives, some positives. When it is 0, so y equal to 2 power 0, we know. So when it is to the power 0, we always count as 1. Why? That's a very good question, but it is beyond your scope. Let's leave it like, okay, so for anything to the power 0, it is equivalent to 1. Let's remember that one. And so when x is 0, y became 1. X is 0, y becomes 1. Let's take when x equal to 1, y equal to 2 power 1, that is equal to 2. When x equal to 1, y equal to 2. When x equal to 3, then y equal to 2 square, that is equal to 4. 2, 4. When x equal to 3, oh, this is 2, sorry. When x equal to 3, y equal to 2 cube, that is 8. When x equal to 3, y equal to 8. We'll take the negative values also. When x equal to -1, y equal to 2 power -1, we can also write it as half and 0.5. So x equal to -1 and this is 0.5. And when x equal to -2, y equal to 2 to the power of -2, that is equal to 1 by 2 squared, that is 1 by 4. We can also write it as 0.25. -2 and 0.25. So since we got all the values, let's plot the graph, how it looks like. I don't have space, so let me erase this part. So y is little bit taller. So 1, 2, 3, 4, 5, 6, 7, and 8. And here -1, -2, -3, -4. This is 0. 1, 2, 3, 4, 5. -1, -2, -3, -4. 1, 0. When x is 0, y is 1. I'll use a different color. X is this axis, y is this axis. When x is 0, y is 1. When x is 1, y is 2. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. Here. So I wrote these numbers closely, but it is somewhere here. When x is equal to -1, y is still positive. What is it? 0.5. That is half of it here. when x is minus 2, it is 0.05. That is somewhere here. So as x negative, or to say, if it goes on the negative side, becoming decreasing. So because minus 1, minus 2, if it goes like this, so if it goes on the left side, the value is decreasing, right? You see that minus 1, minus 2, minus 1 is greater than minus 2, right? So when x decreases in the negatives, it never goes negatives, because always like, okay, even if it is x equal to negative 100, what is y? It is 2 to the power of negative 100, that is equal to 2 to the power of 100, 1 by 2 to the power of 100. This is always positive, you see, numerator is positive, denominator is positive, so the final value is positive. Yes, when x is decreasing, so if it goes negative, even if it reaches at negative 100, so the final overall y value is positive, even if it is at 1000 also. So because it is 1 by 2 to the power of 100, so it is, the value is much lesser. So if I go to 1000, it is still positive, even lesser than that 1 by 2 to the power of 100. So it will be gradually reducing, so like this, but it never touches 0, sorry, because we can't do it on board. So it will be almost becoming 0, like 1 by 2 to the power of 1 lakh also. When x is negative 1 lakh, the overall value is 1 by 2 to the power of 1 lakh. It will be very less, but it is not 0. So yeah, it's like that. So negligible, but it is still not considered as 0. So it is always be like this. So once it comes into the positives, it will go very fast. You see that, okay, the way it is getting accelerated. If you see that, when it is at 0, it is 1. When it is 1, 2. 2 becomes, when it is y x equal to 2, y become 4, and 3, 8, 4, 16. So it is doubled up so fast. So by the time it reaches 100, it will be going somewhere all the way to the sky also, like it will go that rapid. So it will go exponentially like this. So the sharp at 4, it reaches 16, 5, it reaches 32, somewhere on top. So on the negative side, it is almost touching 0. From there it starts and it will go like this. So it is, in English, it is called exponential growth. So this is called exponential growth. So it appears to be smaller, but slowly, once it picks up in the positives, it will go rapidly. So very fast acceleration. So this is how the graph looks like for 2 to the power of x. When y equal to x square, the graph looks a little bit slower. Like, okay, I can plot all three in the one graph and let's compare. So why we are doing all these things? Why we are plotting different types of graphs? So first I want you to understand how these graphs looks like. That's what I explained when y equal to x, y equal to x square, and y equal to 2 to the power of x. So this is all graphs looks like. So what we can derive is, like, so far when x is something, we derived y. Why can't we do it in opposite way? Let's pick y and let's figure out what is x value. So when y is 1, x is 0. When y is 2, x is 1. Like this. When y is 2, x is 1. When y is 0, x is 0. When y is 4, x is 2. These are good. Let's take in between values. So what would happen when 1, 2, 3, 4. I think I've plotted one. Okay. 1 2 3 and this is 4. Okay, so let's take when y equal to 3. This is 3. Okay, so when y is 3, I'll use a different one. So brown is like, okay, we are doing it in a reverse way. When y is 3, we can go to put a dot. This is y3, and what is the x value? This is the x value. We don't know the x value, but we are doing it in a reverse way. First we are picking a y, then corresponding x. So when the graph is plotted, you can go when x equal to 3.5, you can go and you can go to pick the y value, or else you can do it from reverse way also. Once the graph is plotted, you can do from x to y, y to x. So you can pick a x value and you can take you can get a corresponding y value. If you pick a y value, you can do corresponding x value using the graphs. That's the advantage of the graphs. So here y equal to 2 power x. So here we want to determine what is the x value for certain reasons. Like, okay, so y equal to 2 power x. When x equal to 5, you can easily get y value. Y equal to 2 to the power of 5, that is 32. That's easy. What if, like, okay, when y equal to let's take 5, what is the x value? Y equal to 2 power x. Something hard to find out, right? But using the graphs, we can easily figure out. What we have to do? We know the things. This is y. We'll do it in a reverse way. We have to draw this one and plot the corresponding x value. So I don't know whether it is above 3 or less than 3, but it is somewhere here. Okay, I'm just telling you that, okay, how we can do a reverse, figure out reverse values. When y is given, how to find out x? Plot a graph, then draw a line from y and you will get the x value. This is how we figure out the x values. So when y equal to 2 power x, mathematically it is little bit difficult with the numbers, but with the graph it is very, very, very easy. Go 5, draw line, you get the answer. But only one condition is you should be good at drawing. So you can't do like this, okay? For like me, I'm swinging like this. It has to be as smooth as possible. So it should be very, very smooth like this. So when you draw very smooth, you will get an accurate value. So that's where we use all the graphs, and you learned how the y equal to 2 power x graph also. So there is one other concept that maybe you can say mathematicians introduced, log. I will tell you. So plotting, like, okay, so when y is given in these exponential cases, like 2 to the power of x. So not only 2 to the power of x is called exponential. There are many. 3 to the power of x also exponential. 5 to the power of x also. All these are exponential. When x is at the power position, so that is always like a exponential graph only. So these are all exponential graphs. So not only 2 to the power of x, 3 to the power of x, 5 to the power of x. Any number, the power is x, where the variable is, that is called exponential. So for example, okay, we will get a question like 15 equal to 5 to the power of x. So in some hurry, some people think like it is 5x and make x equal to 3, but it is wrong. So you need to think a little bit wiser. So it is not 5x, it is 5 to the power of x. So in that case, it will be like, what you have to do? You have to draw a graph for when phi equal to when x is 0, y is, you have to think like this is y equal to 5 power x, and you have to plot a graph. It will be similarly like this. And when y is 15, you have to take the x value. This is the value of x. That's how you determine the value of x. So our scientists introduced a log. I will explain you shortly.